At Class D, more optimization. Also, notably, a much shorter homework assignment than some of the previous ones, right? Just 5 questions, but they are all about optimization. So, be nice for everybody. Let's read the question. The rancher wants to build an enclosure for his animals. The fencing material for 3 sides costs $2 per foot, and the material for the 4th side costs $1 per foot. They didn't say it was a rectangle, but they said there was 4 sides. I guess you could make like a parallelogram if you were trying to do something weird, but they should have told us it's a rectangle because it's meant to be a rectangle. If the rancher can only afford to spend $500 on the enclosure, what dimensions should the rectangle be to maximize the total area? Let's draw a picture. Here's my rectangular enclosure. Come on in, let's see that survey. And thanks. I want to label the sides. Again, we're going to pick labels so that we don't use more variables than necessary. Right? If I call this side, whose length I don't know, X, I'm also going to call that side X. Even though it might have a different cost associated with it, I'm still going to use the same name for things that have to be the same. So this is X, this is also X. They're the same length. And if I call this Y, this is also going to be Y. They're the same length. Or I could use totally different lenses, right? We could use L and W. Maybe let's change it up. Well, I mean, you guys probably already all wrote down X and Y. I shouldn't change it in the middle things. Next time I'll use L and W. I know it's like terrible. Every someone writes something down, they're like, I'm going to do it differently. Be consistent. So now we have to also think about how much each side costs. So it doesn't matter which one we pick. One of them is going to be different than the other ones. It could be this one. It could be this one. In the notes that are already posted from last time I did this, I chose this side to be the $1 per foot side. I'm going to do it differently just so if you want to look at both of the completed notes from last time and from this time, you can see that it doesn't actually matter which way you do it. You'll still get the same answer. So we're going to say that this side is the side that costs $1 per foot. And the other sides, welcome. Let me see your thing. And also grab some notes. The other 3 sides are going to cost $2 per foot. So I do have to ask you to leave.
I have my testing appointment today.
I know, but if it shows, so if that's the color it's showing me, you're not permitted to be in the room. I'm sorry.
That's okay.
So I would encourage you though to join on Zoom. It's totally an option. There are other people on Zoom as well.
Okay.
But do grab some notes as well. Thanks. So this one is $2 per foot. This one is $2 per foot. And this one is also $2 per foot. And I'm putting the dollar signs in the wrong place sometimes. Sorry about that. So that's going to help us when we start writing our constraint equation. But before we get to the constraint, we should be thinking about what do we want to optimize? Well, we want the dimensions that maximize the total area. So we're trying to maximize area. So we're going to maximize area equal to a rectangle is just length times width, or one variable times the other, right? X times Y in this case. And as is typical, well, maybe not always typical, but as is often the case, we're going to have a thing we're trying to maximize that has 2 different variables. And we only really are able to maximize functions of one single variable. So we have to use some other constraining piece of information to get some relationship between those 2 variables so that we can get rid of one of the variables. In this case, it's all about the cost. So we have $500 to spend. And we're going to spend it all because we want to make the fence enclosure as big as possible. So how much is our fence going to cost? Well, I mean, we're going to spend $500, but how are we going to determine how we're going to spend it? Each of these sides costs $2 per foot. So for example, over here, let's say we made a fence, a rectangular enclosure, and let's say we made the X side 10 feet long. I don't know if this is really not the answer. I'm making up numbers here. And let's say we made the Y side 20 feet long. This is just for pretend. If our fence had those dimensions, how much would it cost? Well, how much would this side cost here that's $1 per foot? How much would this side cost? How much would this side cost? And this side also. Right, okay. So you got it, right? We take the length of the side, you multiply it by the dollar amount to see how much that side costs. Well, the lengths are actually unknowns. So instead of taking 10 and multiplying by 1 and 10 and multiplying by 2, we're going to take x and multiply by 1 and x and multiply by 2. So our cost, which is our constraint, is going to be, let's see, 2x plus 1x plus 2y plus another 2y, and that's going to have to equal $500. I didn't write the dollar symbols because it just kind of get in the way, but you totally could write them if you wanted to. Question? I can zoom in, but not a bit. I have, unfortunately, very limited zoom options. Great. You just have to remind me to make sure to keep everything in frame, because otherwise I will not. Why is the other x $2 and not $1? So the other x is $2 and not $1 because of the way the problem is worded. So the problem says the fencing material for 3 of the sides costs $2 per foot, and the material for the 4th side costs $1 per foot. And we just arbitrarily picked one of the sides to be $1 per foot, and then the other 3 had to be 2. We totally could have picked either one of these, but yeah, but it's not the case that, right, one of the x's has to be 1 and one of the x's has to be 2 for this particular setup. That's the only way it's going to work. All right, so we're going to take our constraint and we're going to simplify things first. 2x plus 1x is 3x, 2y plus 2y is 4y, and that's going to equal 500. And now we're going to try and solve for y. And it's interesting. I'm seeing, sorry, I'm just trying to see one thing. Oh, no, I know what's going on. Okay. So for this particular one, it doesn't look like there's one choice is better than the other to solve for. Right, you can totally solve for x or for y. They both look kind of gross. I'm going to pick to solve for y without any good reason. Just, well, okay, I have a slightly good reason. I know 500 is divisible by 4 evenly, and I know 500 is not divisible by 3 evenly. That's why I'm happening to choose y to solve for here. But really, you could pick either one. So let's solve for y. For y equals 500 minus 3x, and then divide by 4. 500 divided by 4 is 500 divided by 2 twice. 500 divided by 2 is 250. Oh yeah, thank you. 250 divided by 2 is 125. So if you're ever having trouble dividing by 4, it's usually easier to do division by 2 times. And then 3 divided by 4 is 3 divided by 4. You could also use a decimal of 0.75. That's not the choice I'm almost ever going to make. But that doesn't mean you can't make that choice. But fractions usually do work out nicer. So then we're going to take that y and we're going to plug it in for the y there. So now we're going to have our new area equation is going to be x times y. But y is now 125 minus 3/4x. We do need to multiply it out. So I'm going to get 125x minus 3/4 times x squared. And we're just distributing that x. And then I think it's worthwhile to rewrite it in the order of highest power first. You don't have to, but it might help you make sure that you don't make a small error when you find the vertex. Okay, so there's my area equation. And I want to find the vertex because watch, I should ask, does the parabola that represents the area here open upwards or downwards? That means the vertex is going to represent the exactly. So the x coordinate will be the x coordinate, right? It'll actually what x is supposed to be. And the second coordinate will be whatever the maximum area is, which we haven't been asked to find. So we're not going to find it. So finding the x coordinate of the vertex, Vx is going to be, oh, I made a small mistake when I wrote this down here. I forgot the x there. My Vx is going to be this negative b over 2a, which is going to be, so b is 125, and 2a is 2 times negative 3/4. Oh, that's kind of gross. Let's do a little bit of simplifying. So that's going to be a negative over a negative is going to be a positive. So I can drop those negatives. And we would expect, right, we would expect x to be positive. It doesn't make a lot of sense to have a side length with a negative value. 2 times negative 3/4 is, or I'm dropping the negatives. So 2 times 3/4 is 3/2. And then to divide by a fraction, we're going to multiply by its reciprocal. That's 125 times 2/3. So we end up getting x equal to 250 thirds. And I would probably leave it like that. You could, there's not a lot you can do. Oh, you guys can't see that, sorry. I would leave it like that. You could write it as 83 1/3 or 83.333 forever. Like that. Sorry, yeah, I know there's that one spot there. So that's our x coordinate. That's how long the x side needs to be so that we get the most area. But we still need to find the y side. So I'm going to go back to my constraint where I've already solved for y. And now I'm going to plug in our x value. So we're going to get y equal to 125 minus 3/4 times. This is an excellent moment to notice that using the fraction way, right, this is going to be a lot nicer. So if I plug in 250 thirds for x, I get some nice canceling happening. The 3 here and the 3 here do cancel. And you get 125 minus 250 over 4, which you can reduce to 125 over 2. And I should have made this 250 over 2. This is 250 over 2 minus 125 over 2, which is 125 over 2. That's our y value. And this is our x value. Or using decimals, y would be 62.5 and x would be 83.33333 forever. And those are the values that maximize the area of this enclosure while only spending $500. And so I will just point out, if you look at the other version of the notes that are posted on Canvas, you will see that the values are switched. You'll see that y ends up being 250 thirds and x ends up being 62.5. And the reason for that is the one that's 62.5 feet long, or the one that's 125 divided by 2, needs to be the one that's associated with both sides being $2 per foot. And so when I made the choice to make the variables different, you ended up getting them their answer splits. It's still the same right answer, right? You're still using the same 2 values. They're just playing the opposite roles. So it's totally fine to make whatever choice. Just be aware that your answer might seem slightly different, but it's still really the same. Questions? Yeah.
Do we have to write a syntax for the answer?
I don't think so. I mean, but you know what I should do though? I should include some units, right? I should really say that y is 125 over 2 feet and x is 250 over 3 feet. But no, I don't think you need to write any words specifically. Sometimes yes, not here. It's pretty straightforward what we are saying with our numbers here. Other questions?
With the homework last night, I kind of noticed that the x is usually twice as much as the y when solving these kinds of problems. Is that not?
That's not generally true.
Okay.
That happens a lot because of various things that occur, but I wouldn't take that observation to heart.
Okay.
You will see over your career when you get to optimization and calculus that there are some trends that do happen because of the way physical shapes work. But
Okay.
yeah.
So like with the homework last night, there was like one where it was 0 because like one side was like using like the side of like the barn.
Okay.
And I was like, how would you like do that?
So the thing is, when you have a barn, you don't have to use fence on that side.
Yeah.
So if you're doing a whole barn situation, if this is the barn, here's my fence I'm gonna build. This side length is X, this side length is X, this side length is Y. And, oh, thank you, yeah, of course. Sorry, if that's our barn and this is our fence, then if we're trying to set up, like, let's say we are, just trying to make up some numbers here. We have, let's say we have 600 feet of fence. Then, and we're trying to maximize area. Then we're going to maximize area equal to X times Y. And our constraint is going to be 2X plus Y equal to 600. There's nothing to be said about this site because we didn't have to put any fence there. That's the whole idea. That's why we do that with the barn. So we're saving money, right? We're using the barn as one of the sides of our enclosure so that we don't have to build it. Yeah. Okay. See notes. All right, let's look at this next one. On screen. Find two numbers whose sum is 1 and the sum of the squares is minimized. Note the sum of the squares of X and Y is given by SS for sum of squares equals X squared plus Y squared. Okay, so they're already given us the thing that we're trying to optimize, in this case, minimize. So we want to minimize SS equal to X squared plus Y squared. And as before, we have something we're trying to optimize that has two different variables in it, which we definitely need to use a constraint to eliminate one of those variables. So what's our constraint here? What do they tell us about the two numbers? They have to sum to 1. So is it going to be X times Y equals 1, X minus Y equals 1, X plus Y equals 1? What am I looking for? Right. Constraint is X plus Y equals 1. And then again, we can solve for either variable. And here, it really doesn't matter. Right? It's really virtually the same either way. Let's go ahead and solve for X in terms of Y. So X equals 1 minus Y. And then we're going to plug that back in to the thing we're trying to optimize. I want to reiterate, because I don't feel like I can say it enough. The thing you're trying to optimize should never be equal to a number. Right? You're trying to find what that number is that, well, you're not actually really trying to find it, but that's kind of the goal. Whereas the constraint is always equal to some number that's limiting what you're able to do. So let's go ahead and throw that back in. So now we're going to minimize the sum of squares, which is going to be 1 minus Y quantity squared plus Y squared. And we're going to need to multiply that out. That's going to be 1 minus Y times 1 minus Y plus Y squared, which is going to equal, let's see, 1 minus Y times 1 minus Y is 1, minus Y plus Y squared plus Y squared. And that's the whole thing foiled out, plus Y squared. So our sum of squares, simplifying it, thank you, yes. I've got a Y squared plus Y squared, so a 2Y squared. I've got a negative Y minus Y, so a minus 2Y plus 1. So I really usually like my vertex notation. I don't like it for these problems because I want to write the first coordinate of the vertex as Vy, but we almost always think of that as the second coordinate of the vertex. So I'm just going to write the first coordinate of the vertex. So negative B over 2A is going to be negative negative 2 over 2 times 1. I feel like I'm making it, no, not, whoa, no, it's not that. What is it really? Right, I should have 2 times 2, not 2 times 1. My A value is definitely a 2, not a 1. Luckily, it's easy to turn a 1 into a 2. So I've got positive 2 over 4, which reduces to 1/2. Okay. So that's our Y coordinate. Or I should say that's our Y value. It's the first coordinate. Thanks, yeah. So we get y equal to 1/2. And then we need to find x. So luckily, we've already got an equation for x. We know that x is equal to 1 minus y. So plugging that in, it's going to get us x equal to 1 minus 1/2, which is also equal to 1/2. Yes.
Why is that our y value when negative b over 2a is the Vertex defined
So excellent question. So if I was graphing this parabola, the thing we think of as the y thing, which is the output, is the sum of squares. And the thing that we think of as the x thing, which is the input, is in this case y, which I know is not lovely, but sometimes that's the issue. So if you're going to graph this parabola, in fact, let's actually go ahead and find the the minimum sum of squares. So if we plug these back into the original equation, our minimum sum of squares, I know we weren't asked to find it, but it's worth finding, is going to be 1/2 squared plus 1/2 squared, which is maybe slightly confusing in that it's also going to be 1/2. Because 1/2 squared is 1/4 plus another 1/4 is 1/2. So maybe slightly unfortunate that all the numbers are the same. Let's go ahead and look at the graph of this. So if I was going to graph this, here's what it would look like. So my vertex, well, so I should say my horizontal axis is the y-axis, because those are my inputs, and my vertical axis is the sum of squares axis, because those are my outputs. X isn't occurring anywhere on this graph. My vertex is when y is 1/2 and the sum of squares is 1/2. So there's my vertex. And it opens upwards. So what we're saying is when you get a y value of 1/2, you get a minimum sum of squares value, which also happens to be 1/2. And if y was anything larger or smaller, the sum of squares would be bigger. For example, let's pick two different numbers real easy. What are two other numbers that are not both 1/2 that add up to 1? Someone tell me anything.
1/4 plus 3/4.
Sure, making my life hard. All right. I was really hoping for 0 and 1. I will. Yeah, thanks. 1/4 and 3/4. Fine. No, it's okay. So here's the thing. These values, right? We've got a y value that's 3/4. I'm going to go back to the picture for a second. We're right here. We should get a larger sum of squares because we've picked not the minimum point. Let's see if it's larger. So 1/4 squared plus 3/4 squared is going to be 1/16 plus 9/16, which is 10/16, which reduces to 5/8, which is definitely bigger than 1/2. So we have evidence that what we've done is correct, right? We found the y value that actually gives you the minimum sum of squares, and there is no other y value that's going to give you a smaller sum of squares. And what I really want to make sure everyone's cool with is nowhere on this graph do we know anything about what the x value is. If the x value has nothing to do with this. This is all this graph is telling us is about what the sum of squares is based on what the y value is. That's it. So I know it can be a little bit dicey, but that's what's happening. Yeah.
Why does it say y equals 1/2? Or excuse me, it says y equals 1.
It doesn't die because of bad notation on my part. I was labeling the point 1 here, and then I was writing the point y equals 1/2 down there. Sorry about that. Yeah, that's excellent question. Good point of clarification there. Other questions? So, when you're finding the vertex of your parabola, the first point is always the dimension of the thing you're talking about. In this case, the first point here is the y value that we're looking for. And the second point of the vertex, which I know happens to be the same, unfortunately, the second point of the vertex here is representing your maximum or your minimum value. And I will say, if we look back at this previous example we did, where I know we got some not lovely numbers either, you know, y is 125 over 2 and x is 250 over 3, but we could find the maximum area. The maximum area would be this times this, 125 over 2 times 250 over 3. And that would be the second coordinate of your vertex. In fact, you guys can see it. Look over here at my area equation. If you plugged in x equal to 250 over 3, this is exactly what the corresponding y value is. So you get those two numbers together, and this is exactly the second coordinate of your vertex. So first coordinate of your vertex is always one of the dimensions you're trying to find, or one of the things you're trying to find, typically, because usually that's how it's asked. And the second coordinate of your vertex is always your optimized value of the thing you're maximizing or minimizing, which you're usually not asked to find, right? Most of the time, no one's like, tell me the maximum area you enclose. No, they're telling me the dimensions of the thing you're trying to build, because that's more useful, right? It's not helpful to know you built a fence that is 600 square feet. It's helpful to know that you built a fence that is 10 feet this way and 60 feet that way, or whatever. Like trying to pick numbers that actually multiply to 60. Good. All right. 1/4 and 3/4. Okay. Making my life challenging. All right. I mean, but you can pick 0 and 1 also and see that the sum of the squares is bigger than a half. All right, let's look at another one somewhere. Find the point on the graph y equal to the square root of x closest to 8, 0. Okay. I'm going to draw a picture. I'm going to draw y equal to the square root of x. And so if you're drawing the square root function, for me, the easiest way to draw it is to plot like 3 or 4 points. And the points I'm going to plot are when x is 0 and y is 0, when x is 1 and y is 1, because the square root of 0 is 0 and the square root of 1 is 1, and when x is 4 and y is 2. And if I'm feeling especially like graphing more, I could also plot when x is 9 and y is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then just try and make it not look terrible. Really, you could draw it doesn't really have to look good at all. You could draw a terrible picture and it would still show you the information you need. And then I want to, the next page, I want to find the point on the graph of this closest to 8, 0 right there. So there's 8, 0. And there's some point on this graph that's probably here-ish. I don't exactly know what it is. And since I don't know what it is, I'm going to give it a different name, or a name that represents it as unknown, right? I don't know if it's the point like 7, square root of 7, or some other weird thing. I'm going to call it x, y. And if we're trying to find the point x, y on that graph that's closest, we're really trying to minimize what? The distance, which is the square root of, you could say, so you can go either way. You could say it's 8 minus x quantity squared plus 0 minus y quantity squared, but it's almost always a better choice and easier calculation-wise choice to do the variables minus the other things. Meaning, I would rather write x minus 8 squared plus y minus 0 squared. It's always going to be the nicer way to approach this. But remember last time, or maybe not, instead of minimizing the distance, we're going to minimize the square of the distance. So we're going to look at instead the distance squared, which is just the same thing without the square root. And I dropped the minus 0 there because y minus 0 is just y. Okay, so as is typical, we're trying to minimize a thing that has more than one variable in it. We're going to use a constraint to eliminate one of those variables. What's our constraint? What has to be true about that point? It has to be the closest, but what curve does that point have to live on? It has to live on, what is that curve? Right, it has to be on there. So that's our constraint. It has to be true if that point is on that curve that y is equal to the square root of x. And then we can substitute that in to the thing we're trying to minimize. So now our distance equation, or sorry, distance squared is x minus 8 squared plus the square root of x squared. And the square root of x squared is just good old x. So let's simplify this a bit. X minus 8 quantity squared is x minus 8 times x minus 8. Oh, am I off? Sorry, yeah. Plus x. And then foiling this out, we get x squared minus 8x minus 8x plus 64 plus x. And then simplifying, x squared minus 8 plus 1 is minus 16 plus 1, which is minus 15x plus 64. Ah, yep, sorry. The price of being zoomed in. Okay, so now to find where this has a minimum, we're going to find the x coordinate of the vertex. It's negative 15 over 2 times 1, which I'm going to write as 15 halves. Or you could write as 7.5. That is the x coordinate on this curve. Oh yeah, question.
What is 8x minus 8x is 16x?
Right, but then we also have a
Oh,
plus x right there. Yeah. So then, to find the other part of the coordinate on the curve, right, to find the y coordinate on this point, well, y has to equal the square root of x. So we're just going to take our x value and say, okay, if x equals 15 halves, y has to be the square root of 15 halves, which doesn't really simplify at all. It just is what it is. So I would say that the point that I'm looking for that is closest to the point 80 that's on y equals root x is 15 halves, comma, square root of 15 halves. If you happen to be wanting to do something like find the y coordinate of this vertex, you're actually finding the distance squared coordinate of the vertex. So just as a point of interest, not that we're being asked to do this at all, if you wanted to find the second coordinate of the vertex, it's not pretty, right? It's 15 over 2 squared minus 15 times 15 over 2 plus 64, which is going to be 15 squared is 225 over 4. 15 times 15 is 225. Oh gosh, that's something.
what is that?
What is it? This is, so actually that's an excellent question. That's why I was talking. What is that? That is what the minimum distance squared would be. I suppose we can simplify it. This simplifies to 225 over 4 minus 450 over 4 plus 256 over 4. So you get negative 225 plus 256, which is going to be 25 plus 6, which is 31. That is the minimum distance squared. So this distance right here is the square root of 31/4. I'm sorry. Question.
On another problem, if it says like find the dimensions of something, could you write the answer and make the point form like comma blank, or would that be wrong?
It is kind of wrong. Yeah. I mean, I wouldn't like, it's not terrible, but they're not asking for a coordinate, right? So it really is better to say x equals this and y equals this.
Okay.
And they're really not making an ordered pair. Okay, good question. So yeah, so if you found the y coordinate of the vertex, you're finding the minimum or the maximum value of your thing, which in this case, the minimum value is of the distance squared is 31/4. So the minimum distance is the square root of 31/4. Kind of interesting, not at all necessary. But I just want to keep emphasizing the fact that we typically don't need to find the second coordinate of the vertex. Yeah. Also, you really don't need to ever find it because even in like say one of the fence problems, if someone asked you to find what the maximum area was, instead of finding the second coordinate of the vertex, it's usually easier just to find the two dimensions and then multiply it together. So really, you almost never should be finding the second coordinate of the vertex in these optimization problems. I won't say never, ever, but like almost never. This question seems out of place, but worth doing. Find the equational line connecting the vertex and y-intercept of the parabola given by the equation f of x equals 2 times x minus 3 squared minus 7. Definitely not an optimization problem, but still something people should probably see an example of. So let's find the things. Let's find the vertex. So here's the thing about this particular parabola. It is written in the vertex form. The vertex is meant to be very easy to see here. The vertex is the x, or I should say, the x coordinate of the vertex is the value of x that makes this part 0. What is that value? And then the y value is just whatever's over here. Or it's what you get when you plug in 3. You plug in 3, 2 times 0 squared is 0, minus 7 gives you a minus 7. So why is it 3? Well, let's talk about that. Another way you can find the vertex is actually doing it the quote unquote long way. You could multiply this whole thing out and write it in the more standard form of a parabola. So let's do that. Good. Okay. So if we multiply this out, you get 2 times x squared minus 6x plus 9 minus 7. And then that's going to be 2x squared minus 12x plus 18 minus 7, which is 2x squared minus 12x plus 11. So now let's find the vertex in the more typical way. The x coordinate is going to be negative b over 2a, which is, sorry, there shouldn't be a parentheses there. It's terrible. Sorry. Let's try that again. The x coordinate of the vertex is negative b over 2a, which is going to be negative 12 over 2 times 2, which is 12 over 4, which is 3. And then the y coordinate of the vertex is going to be, well, let's see, I plug in 3, I get 2 times 3 squared minus 12 times 3, that's 11. I get 2 times 9, which is 18, minus 36, plus 11. I see the usual thing that happens, where the first term is half the second term and they're opposite signs. Always happens when you find the y coordinate of the vertex. And then 18 minus 36 is negative 18, plus 11 is negative 7. So my vertex is the point 3, negative 7. The whole point, though, is that if it's written like this, it's meant to be so that the vertex is easy to see. One way you can justify this way that the vertex is 3, negative 7 is, well, let me ask you. Oh, sorry, you guys can't see what I'm pointing at. For this parabola here, which way does it open? Up or down? So it opens upwards. Great. And I'm going to draw it like I know what's going to happen. So it opens upwards. And it's got some lowest point. Okay, let me ask you all. If you have 2 times x minus 3 squared, not writing the negative 7 yet. When you have something squared, is it ever negative? No. Can it equal 0? Yeah, something squared can equal 0. What number squared equals 0? 0 squared is the only number that equals 0, or the only number squared that equals 0. Okay, so I want to make this, well, I want to find that point there. If I'm trying to find the lowest point on the parabola, I'm trying to make my y value as small as possible.
Isn't the vertex like a positive 3?
Yeah, exactly. Yes, yeah. It's perfect. So the idea here is I want the y value to be as tiny as possible. And you just said what I was going to ask, which is what value of x do I need to pick to make this part as small as possible? Well, you all just told me the smallest that can be is what? 0. And what did you just tell me the x value has to be to make that 0? 3, right? X has to be 3 so that 3 minus 3 is 0 and 0 squared is 0 and 2 times 0 is 0. And that's the value of x that's going to give us the lowest y value, right? If you pick any other value of x, pick something else. If you pick 4, if x is 4, you get 2 times 1, that's 2, minus 7, that's negative 5. That's a higher value than the point 3, negative 7. Oh, sorry, I graphed it wrong. I apologize. I'm like, I see. I think and I do. That's how you're asking that question. Because I kind of, yeah. Sorry about that. The graph is, I misjudged here. Apologies. Should really look like this. I don't really care so much about what the graph actually looks like. But that's my point. That's the lowest there. Question. Totally, yeah. So what I'm doing here, I'm not trying to say that you can't just look at this and be like, oh yeah, if it's x minus h, you get the h value, and if it's k, you get the k value. Right? That is what you would mostly do. But I'm trying to offer a little more justification as to why that's actually true. And it's because if it's opening upwards, you're trying to find the value of x that makes this thing as small as possible. And it's the value that's going to make this part 0. And you're always looking for the value of x that makes this part 0 if it's written in the vertex form, which it is, or the complete square form. Hopefully that offers you a little more insight as to why we are doing that. So there's our vertex. Great. What did the question ask us to do? And what else? And the y-intercept. Okay, so the y-intercept, we always find y-intercepts by setting x equal to 0. So we're going to set x equal to 0. And then if I look at my function, which is 2 times x minus 3 squared minus 7, be careful. I definitely have seen many people in the past, when they set x equal to 0, just kind of pretend like this part doesn't exist, but that's not the case. So if we set x equal to 0, we're going to get y equal to 2 times 0 minus 3 squared minus 7. And that's going to be negative 3 squared is 9. Yep. And 2 times 9 is 18 minus 7 is 11. So my y-intercept is the point 0, 11. All right. So now that we found the 2 points, we have to find the equation of the line between them. So here's our 2 points. 0, 11, and 3, negative 7. And we're trying to find the equation of the line between them. We need 2 pieces of information. We need a point. We have more than 1 point. Great. We also need the slope. And if you've got 2 points, you can find the slope of the line between them. The way we're going to find the slope is by using the slope equation. If you've seen calculus before, now is not the time to use it. This is I don't like to say you're not allowed to do certain things, but this is definitely a no calculus zone. Right? We're not using the derivative, nothing crazy like that. We're finding the slope the good old-fashioned way. We're finding the slope between 2 points using the slope. So pick whichever one you want, just be consistent. So you could either do this y minus that y over the corresponding x minus the corresponding x, or vice versa. This y minus that y over this x minus that x. In either case, let's see, here I'm getting 18 over -3. Here I'm getting -18 over +3. In either case, we are getting a -6 for our slope. Great. So we are lucky in this problem in that they've given us a really easy point to use. The easiest way to answer this question would be to use the 0, 11 point. Say, okay, I know y equals mx plus b, which is y equals -6x plus b. And then I can plug in x equal to 0 and y equal to 11 to find the b value. So if y is 11 and x is 0, it's really easy to see that b has to be 11. But you might not always have such a convenient number to use. And since that's true, I'm going to show it the other way as well. Did you have a question? No. I thought I saw your hand go. Okay. So you could also choose the other point. Either point will get you the same b value. So I would have -7 equal to -6 times 3 plus b. And we see, oh, well, -7 equals -18 plus b. Add 18, and 18 plus -7 is 11. So either way, either point you pick will lead you to the correct b value as long as the calculations are right. And then our final answer is going to be y equal to -6x plus 11. So that's how we would do a question like that. We find the 2 points they're asking us for, the vertex and the y-intercept, and then we have to do the work to find the equation of the line that goes through those.